we're going to look at some new identities in here. And we're mainly going to look at cosine, sine, and tangent. And look at these. So I'm not going to derive these identities or anything. They're the derivation of these is can be kind of tricky on the cosine and sine. Sometimes I'll show that to a trig class, but not in pre-calc. Okay, so the idea is what we're going to do is look at angles that are not on the unit circle. I mean, they're not one of the special angles on there that we can combine by adding or subtracting two angles. Like, for instance, 75 degrees, we could write as 45 plus 30, and 45 and 30, of course, are on the unit circle, so that's what we're going to do. 15, same way, you could write that as 60 minus 45. So the first thing we're going to look at is these two identities, cosine sum and cosine difference, okay? I will give you, when we do our exam, we're going to do exam 4 next Monday. We have to have 4 exams. The department requires that. We didn't used to do that. We used to just do 4 exams, and the last exam wasn't the final. It was exam 4. So some of these identities we're going to learn today, I'll give you for that exam. I'll tell you which ones I'm going to give you. So the sum difference identities, I'll give you those identities, and I'll show you how to use these then. So what we're going to do is we're going to find the exact value using the cosine identities on this example here. So we're going to start with 345. So what you'd want to do, you can combine and get 345 lots of different ways. To me, what comes to mind is the most sensible would be 345. But it's up to you how you combine it. You'll still get the same answer. So what I want you to write down, first of all, so just write down that we're going to be doing the cosine of 300 degrees plus 45 degrees like that. And then we're going to follow this identity exactly what it tells you to do. So it goes like this. The cosine sum identity, you do the cosine of first, cosine of second, sine of first, sine of second. Then you have a different sign. So follow the identity. So you basically go cosine 300 degrees times cosine of 45 degrees, and then you do a minus, and then you'll go sine 300 degrees, and then you'll go sine 45 degrees like this. And let me kind of get this unit circle out of the way here. And then basically we use the unit circle to get this put together then, okay? So these problems are actually pretty easy to learn how to do. All right, so what we do then is just look these up on the unit circle. So for instance, let's look at the cosine. The cosine of 300 degrees is the x value. We know the cosine of 45 degrees is the x value like that. Okay, so you just plug them in. So the cosine of 300 is 1/2. Cosine of 45 is square root of 2 over 2 like that. Okay, then we'll look up the sine. Of course, the sine's the y value, so look up the y value of those two, then we'll put it together. So we have minus this. The sine of 300 is negative root 3 over 2. And then the sine of 45 is root 2 over 2 like that. That's it, okay? And then we're going to multiply this stuff out. So again, it's up to you how you combine to get the 345. Just find two angles on the unit circle. The problem's designed so it works that way. Then you can multiply straight across. So this would be square root of 2 over 4. And same thing here. You got two negatives here, so be careful, of course, with your signs and stuff. That would just give you a positive number. And then you would have square root of 6 over 4 like that. And then when you put this together, you already got a common denominator. So the answer we'll just write as, generally I have you write it as square root of 2 plus square root of 6 all over 4. That's it. Okay, that's the exact answer of the problem. And with problems like this, if you're doing your homework, usually students don't have much trouble doing these types of problems. You can check pretty easily on your calculator. I'm going to pull up my calculator and just show you on a couple of problems here and there how you can check and verify. So that's nice to know how to do. So what I would do, I think my calculator, I need to change this back to the right mode and everything here too. So if you want to try this on your calculator, this is kind of a nice thing to know for homework and stuff. You would want to be in degree mode since we're dealing with a degree measure. And then this is all you got to do. You just go cosine of 345, and that's a decimal answer. And then you can just take your answer and see if it's the same. The way you do the answer is like this. You would go square root of 2, and you'd want to have that numerator in parentheses so it calculates right, plus square root of 6, and then divide the whole thing by 4, and it should be the same. Okay? What in the world did I? Oh, I left off a parenthesis. That's why I did that. Okay. Did it work? Anybody that tried to do that? Okay, it'll work. Just be sure that you close the parenthesis and be sure that you have parentheses around that numerator so it does that numerator first. So let me try one more time, just to give you the idea. Okay. All right. So I think it'll work. There we go. Voila. Okay, we're good. So you can check your answer on these things. So that's the exact answer to the problem. That's all there is to it. Okay? Everybody with me so far? Okay, so just follow the identity. I would suggest on this one, to me, it's just as easy to convert to degrees. I think when you look at my math lab, they'll probably show you something a little bit different. It doesn't matter. Just go to degrees. It's usually easier to work with degrees to me. So I'm going to go 5 times 180 over 12 and see what that is. And the problems I give you are designed so it works out that way. So what we end up having is we have 75 degrees like that. So then we're going to try to just go through and put this together then. Okay. So how would you put 75 degrees together? What would be logical to you? What are two angles on the unit circle that add to 75? 45 and 30, right? It's up to you how you do it, but just kind of keep it simple. So let's do it this way. Let's go cosine of 45 degrees plus 30 degrees like that, okay? And that's the same thing. The answer on these problems a lot of times looks real similar too. So we just go like this. The identity goes, you do the cosine of the first angle times the cosine of the second angle. Then you do the opposite sign. So instead of plus, you do minus. Then you do sine of 45 degrees, and then you do sine of 30 like that. Okay, and then you just look everything up on the unit circle. So let's see, I'll highlight the cosine of 45 and 30 would be those two numbers. And the sine, of course, is the y value. So you just do this then. So you would end up having cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And then minus, and let's see, sine of 45 is root 2 over 2. Sine 30 is 1/2. So the answer is going to be a little bit different, but it's going to have the same numbers in it. So you would get square root of 6 over 4, and then minus square root of 2 over 4. Then just write the answer like this. Just write it as square root of 6 minus square root of 2 over 4, and that's the answer. What you'll find on these problems is you'll pretty much always have, if the angle is inside of a quadrant, you'll always have a square root of 6, a square root of 2, and a 4 in your answer. It'll always work that way, okay? So that's how you do that. All right, so usually that problem, those kind of problems aren't very difficult for students. Does that look okay to everybody? Okay, all right. So you want to know those identities. I give you these identities for exam 4. These are identities in calculus. These two you don't probably use too much. Some of the later identities we're going to learn today, you'll use a little bit more than that. All right, so that's what I want to show you on the cosine identity. Next thing I want to look at is just down at the bottom of the page is the sine identity, which works a lot the same way. You have a sine sum identity, and this goes like this. Sine first, cosine second. You have the same sign. There's kind of a way that I remember this. I'll show you that in just a minute. And then it goes cosine first, sine second, and then the sine difference identity has the same sign like this, okay? I kind of do this. I don't know why this sinks in my mind, but it does. The cosine, I just go like this. I go cosine, cosine, sine, sine, difference sign. For some reason, that sticks in my mind. I do the sine one this way. Sine, cosine, cosine, sine, same sign. kind of rhythmically so it sticks in my brain, okay? I'll give both of these identities to you. You just know how to have to apply those things, okay? All right, and let's see. It goes like this. So with the 255, again, what we'll do is we'll look at a couple of angles and see if we can figure out a way to put this together, okay? So let's see. One way to do that, let's see, would be, let's see, 225. I don't think that would work. I think 210 and 45 would work, wouldn't it? Okay, so it's up to you how you put that together. So let's just do this one this way. So we got 210 degrees plus 45 degrees like that. Okay, you can make them add, you can make two angles subtract. It's totally up to you how you do that. Okay, so I remember it like this: sine, cosine, cosine, sine, same sign. So it goes like this. You go sine of the first angle, 210, times cosine of second angle, 45. And then since I'm using the sum identity, I use the same sign, unlike the cosine. Then I do it backwards. Then I do cosine 210, and then times sine of 45 like that. Okay, and then it gets just a matter of looking everything up on the unit circle. So if you did the sine of 210 and the sine of 45, that would be the y values. And if I do the cosine of 45 and the cosine of 210, that would be the x values. Okay, so you just look this up and get this from your unit circle. So let's see, sine of 210 is negative 1/2. Cosine of 45 is square root of 2 over 2. Cosine of 210 is negative square root of 3 over 2. And then the sine of 45 is square root of 2 over 2 like that. So you're going to see a familiar looking answer when you do that. So you'd end up getting, it looks like negative root 2 over 4 minus root 6 over 4 like that. Okay, you already got a common denominator, so just write the answer as negative root 2 minus root 6 all over 4 like that. Okay, that's the way I generally have you write the answer. You can also write the answer this way if you want to. 1/4 parenthesis negative root 2 minus root 6. It's the same idea, okay? And again, if your angles are inside the quadrant, if they're not on an axis, like 90 degrees or 180, then you'll have a root 6, root 2, and a 4 in your answer. Okay, so it's very predictable what you'll get, okay? All right, next one, let's just convert this to degrees. It's just as easy to do it that way. So negative 5, we know pi is 180 degrees, and then divide by 12. So that's negative 75. So we're just going to work out the sine of negative 75 degrees like that. Okay, so we need to figure out how to get a negative 75 out of that. There's a couple of ways to do that. You could do negative 45 plus negative 30 if you wanted to. You could probably find a way to subtract that if you wanted to. It really wouldn't make that much difference. So I think every problem I've done the sum identity on, but it's up to you how you do that. Let's see, is there another way to do that with a difference? I'm just thinking about that. Probably not. Okay, let's just go sine of negative 45 degrees plus negative 30 degrees like that. Okay, just whatever you find. Okay, and then again, the identity is going to go like this. We go sine of the first angle times cosine of the second angle. On the sine identity, you use the same sign. So if you're using the plus identity, you use plus, and then you do everything backwards. You do the cosine of the first angle, negative 45, and then the sine of the second angle like that. So just follow what the identity tells you to do. If you memorize the identity, it speeds up your work a little bit when you do that. Okay, all right, so now all we got to do is just look at the angles. And since we're doing negative angles, you want to pay attention to that. So the cosine of negative 30 would be root 3 over 2. The cosine of negative 45 would be root 2 over 2. And then the sine would, of course, be the y values. So you just put it together and you'll get a very familiar looking answer again. So the sine of negative 45 is negative root 2 over 2. Okay, the cosine of negative 30 is the x value, so that would be positive square root of 3 over 2. The cosine of negative 45 is the x value, so that is positive root 2 over 2. And then the sine of negative 30 is the y value, negative 1/2, like that. All right, so when you put it together, you would get negative root 6 over 4 minus root 2 over 4, like that. And then just common denominator, you can write the answer as negative root 6 minus root 2 over 4, like that. So same type of answer, okay? It looks like the answer to basic to those last two problems I did was the same, okay? And sometimes it will be, okay? All right, so usually students find this to be pretty simple. What do you guys think? Does that look like it's pretty smooth to you? Okay, not that bad. It's just knowing how to put the angle together, knowing the identity, knowing the unit circle. That's what it's all about. Usually that goes pretty nice for students. All right, the tangent is, the identity is a little bit harder just because a lot of times you have to rationalize a denominator. The sine cosine identities are always pretty straightforward. So I'm going to show you the derivation of this identity. I like to derive some of these things. The sine and cosine identities are kind of tricky to derive, but this one's pretty easy to derive because you can derive it based on what we know about the sine and cosine sum identities that I just showed you. All right, so again, I'll give you these identities. You just got to know what to do with them, okay? All right, so let's derive like this first one. So let me show you how to do this. First thing that you want to do is we know that the tangent's the sine over the cosine. Okay, that's an identity we've learned. So we can write this as sine alpha plus beta all over cosine alpha plus beta. Now see, we just learned those two identities, so we can put that together like this. Now I'll have you just write down the identity we just learned. The sine identity goes sine, cosine, cosine, sine, same sign. That's how I remember that. So I go sine alpha cosine beta plus, and then I do it backwards. I go cosine alpha sine beta, like that, okay? And then the cosine identity, I remember cosine, cosine, sine, sine, different sine, okay? All right, it's like a stupid rap, okay, but I have it stuck in my head, okay? So it goes like this: cosine of first, cosine of second, different sine, and then it's sine alpha, and then sine beta, like that. Okay, and what I'll show you on this is how you get this identity out of this. And the way I remember to do this is this. I'll show you kind of what I do in my head. Is I want this thing to become a tangent. I want this whole thing right here to become a tangent alpha. Well, if I divide by cosine beta, we know, cosine alpha. If I do sine alpha over cosine alpha, I'm going to get that. I want that to go away, so I can divide by cosine beta. So when I try to remember how to get this identity, I just sort of try to figure out how I'm going to make it look like the right side. So this is what I'm going to have you do. We're going to multiply the numerator by 1 over cosine alpha, cosine beta, and then we have no choice but to do exactly the same thing to the bottom, okay? And if we do this, everything will just pop out of it beautifully. So let's just kind of write this like this then. So again, I'm doing a distributive property like this. So I'm going to have sine alpha cosine beta, and then I'm going to put that over cosine alpha cosine beta. Kind of, you have to write a lot of stuff on this first step, but then everything falls into the identity. And it's nice to know how to do stuff like this for higher math, because you know, if you need a formula, you're on a test or something, if you can derive it, then that's helpful to you. Okay, so we're going to do that same thing to both the top and bottom. So you want to do exactly the same thing to the bottom. And then everything probably will pop out of it pretty nicely then, I think. Okay. All right, so I'm just taking every piece of that, of the first step I have, and dividing it out. So here's basically what happens. This thing right here that I'm highlighting, that's a tangent. Okay, and of course, the cosine betas cross out. If you look at the next thing, the cosine alphas cross out, and then sine over cosine, well, that's a tangency. Then if you go to the bottom, what happens on the bottom here is I end up getting this. Okay, that would cross out here. So that whole thing there gives you a 1. And then you go to the bottom, what pops out of this is you have a tangent and another tangent like that. All right. So this part, the numerator right here, that would be tangent alpha with that canceling. And then you would have tangent beta. And then the bottom, you have 1 minus tangent alpha, tangent beta like that. So that's how you derive that, okay? And we're not going to look at like stuff like the cotangent sum, the secant sum, cosecant sum. They can all be derived, but we're just not going to deal with those too much. Okay, does that derivation make sense to everybody? Okay, all right. So basically just using the tangent sine over cosine, using the identity formulas we learned for sine and cosine sum. And what we're going to do on the next page, we're just going to do a couple of examples where we put together the tangent identity. These are a little harder to do algebraically than the other ones are, okay? All right, so I think I'll just do 2 of these, and I'll use the unit circle so we can kind of get the numbers that we need to. Okay, so this one, first of all, we're going to figure out how we want to get 15. So how do you want me to get 15 out of 2 angles, either adding or subtracting? What's logical? Probably 45 minus 30. 60 minus 45 also works. It's your call. Okay, so let's just go like this. Let's go tangent of 45 degrees minus 30 degrees. Okay, like that. Okay, that'll work. The 60 minus 45 will give you the same answer. Okay, so it goes like this. The way I remember this one's harder to remember. You go, the numerator is just tangent 45 minus tangent 30. If you just look at the previous page, that's what the identity tells you to do. And then the denominator is 1 plus. I always remember those signs are opposite. Then I just do the product of the tangent of 45 and the tangent of 30 like that. Okay, so that's what I got to work out. And then I'll look at the unit circle to get some of this put together. Some of this I'm going to do up here at the top here. So if I do tangent of 45, what's the tangent of 45 in your head, since it's y over x? That's 1, right? Okay. Remember, that's y over x. You don't have to write this down, but you're just doing root 2 over 2 divided by itself. So the tangent of 45 is 1. So we have that. Okay, if I do the tangent of 30, which I also have to do, again, we're going to do y over x. So we go to this right here. That would be 1/2 over root 3 over 2. The root 2, the 2's cross out. So you get 1 over root 3, and you need to rationalize that denominator probably before you even plug it in. So I'm just going to multiply by root 3 over root 3 to get root 3 over 3 like that. So what I'm going to do is everywhere I see a tan 45, I'm going to plug in a 1. Everywhere I see a tan 30, I'm going to plug in root 3 over 3. Okay, and the algebra in this problem is a little bit more challenging than it is in the previous ones, like I said. So you would end up getting this. You would get 1 minus root 3 over 3. And then the bottom, you would have 1 plus 1 times root 3 over 3 like that. Okay, and there's a couple of things that we got to do. I want the denominators to be rationalized. So First question I'll ask is this. How do I get rid of that 3? I don't want that complex fraction. So what do I do to get rid of the 3? Multiply it by 3, right? I just do top and bottom by 3. And you want to kind of take a couple of steps to get this done, and then that will rid yourself of the complex fraction then. Okay, so we do that. And don't forget, you're doing a distributive property. So you're doing 3 times 1 is going to give 3. Then when you go to the next one, the 3's cross out, leaving you minus root 3 like that. Same thing happens in the bottom. You're doing a distributive, so 3 times 1 is 3. And then when you go to the second part, the 3's cross out, and that gives you that. Okay, now what we need to do now is we got to rationalize the denominator. Okay, so do you guys know how you would rationalize the denominator in this case? You have 3 plus root 3 in the bottom. So just multiplying by root 3 is not enough. You know what to do from your background. Conjugate, okay, 3 minus root 3. Okay, we looked at this a little bit earlier when we were doing more like the algebra part of pre-calc. So whenever you have 2 terms added and you're trying to get rid of a radical, you've got to multiply it by the conjugate. And this kind of idea here, you'll do in calculus a lot. There's a lot of times I can think of where you multiply by conjugates to work with radicals. And then the next thing is you just got to dig into your background and make sure you know how to FOIL with radicals okay. Sometimes I see students have issues with that. So if you do the numerator, we'd have 3 times 3 would be 9. The outside term would be negative 3 root 3. You know, only both things are not in the radical, so you have to write it that way. The inside term's the same idea. That would be minus 3 root 3. And then the last term, you have a negative times a negative, so it's a positive, and that's square root of 9. Or it's the square root of 3 to the second, so that's just 3. You can do whatever you can do in your head. I'm okay with you skipping some steps in your head. I'm going to go ahead and FOIL the bottom part, but you can do a shortcut if you know what you're doing on this. So the bottom, 3 times 3 would be 9. The outside term would be negative 3 root 3. The inside term would be plus 3 root 3. And then the last term would be minus square root of 9. So just be careful with your FOIL. And see the bottom, what happens is the inner and outer cross out anyway. So that's the reason why we use the conjugate. And then the square root of 9 is 3, so we don't have a radical to worry about anymore. So you'd end up having the numerator, you would have 9, and then these are like terms. So that would be minus 6 of those. So that's minus 6. Radical 3, square root of 9 is 3. Then when you go to the bottom, you would have 9 minus 3 like that, okay? And then what will happen is you'll have 9 plus 3 is 12, minus 6 root 3 over 6, and then you can split it up. You can either factor a 6 out of the top or you can split it up. Doesn't make any difference which way you do it. I'm just going to factor a 6 out of the top to get this. So my answer to my problem is going to end up being 2 minus root 3 like that. So you get into heavier algebra on this tangent identity than you do the other two, like I was saying, because typically you have to rationalize with a conjugate, and you sometimes are going to have a complex fraction. It depends on the situation. And again, don't forget, you're doing a problem like this, it takes like 10 seconds of your time to check and see if you're right. So if I was to do the tangent of 15 in degree mode on my calculator, I get this. And then if I do 2 minus square root of 3, I should get the same thing. So it's easily verifiable on your calculator. All right, is there any questions about the algebra on that? Sometimes I see students with algebra issues on this type of problem. That tends to be the hardest identity we work with in this section. Okay? Everybody okay? All right. So let's do one more with the tangent. That one's probably the hardest one that you would get into algebraically. Let me see how this one goes. But again, I'm just going to do degrees. So I'm going to go 7 times 180 over 12. And then that would be 105. So we're going to work out the tangent of 105 degrees. Okay, so what's a simple way to put together 105 degrees out of two angles? Yeah, 60 and 45 would be one way. It's up to you, whatever you find, but this is probably a logical way to approach this problem is just go 60 plus 45. Okay, like that. Okay. And then the identity goes like this. It's similar to the last identity. You go, the numerator is tangent of 60 plus tangent of 45 degrees. And then the denominator just goes 1 minus tangent of 60 times tangent of 45 like this. I think this one algebraically is a little bit easier than the last problem. Okay, so what we do is we want to look at the tangent of 60 on the unit circle. You can do that in your head if you want to. That's square root of 3 over 2 over a half. So that's square root of 3. And then the tangent of 45, just like the last problem, is going to give you 1. So what we'll do is tangent of 60 is root 3. So we'll have that. And then tangent of 45 is 1. So we plug in and then we simplify. Okay, so let's see how this one works out. So what we'll end up having is square root of 3 plus 1 in the numerator. The denominator will be 1 minus square root of 3 times 1. So we end up with root 3 plus 1 over 1 minus root 3 like that. Okay, now again, you don't have the complex fraction like we had the last problem, but you do have to rationalize. So how do you rationalize this one? What do you multiply by? 1 plus square root of 3. It's always the denominator you look at. So you're looking at the conjugate of the denominator. So multiply both the top and bottom by 1 plus square root of 3 like that. Okay? And we'll work this out. Just again, do the FOIL. So if you do the top, the first term would be root 3. The outside term would be root 3 times root 3, which is root 9, which is 3. And you can do stuff in your head if you want to. Inside term is 1 times 1 or 1. And then the last term is 1 times root 3 or root 3 like that. Okay? This time in the denominator, just take a shortcut. You can always just do a shortcut. So you just do the first and last term. So the first term, 1 times 1 is 1. The last term is square root of 9 or 3 like that. Okay, then this one will go together kind of like the last one. It'll have a very similar looking answer. So you'll end up getting, these are like terms. So you have 1 plus 1 or 2 root 3. Then the square root of 9 is 3. So you have 3 plus 1. The denominator is 1 minus 3. So then we would end up having 2 root 3 plus 4 over negative 2 like that. And what you can do is you can either factor out a 2 out of the numerator, or just a different way to do this, I could have done this on the last problem too, is you can split it up, the fraction up into 2 parts like that. Okay, the 2's are going to cross out here, leaving negative root 3, and then 4 over negative 2 is negative 2. So it's a similar looking answer to the last problem. And this is kind of how the tangents work out, depending on what angle you're doing, is they have kind of a similar looking answer as well. Okay, but the algebra is what you have to pay the most attention to on that tangent identity. Okay? Okay, are you with me? Okay, now I'll give you these identities. I just want you to know how to work with these things, with these type of problems, just given an angle and being able to crunch those out okay, all right? Okay, the other thing that we can use this for is to develop identities. This is a pretty short section, so we mainly just look at learning those 3 types of identities. These are things that are kind of nice to go through because you can relate this to graphing pretty well. So we're going to use the sine sum identity on this one. So we're going to go ahead and just put this together like this. So again, the sine identity I think of is sine, cosine, cosine, sine, same sign. It's got the same sign. So we'll go like this. We'll say sine of x times cosine of 2 pi. Then we do the same sign, and then we do it backwards. Then we do cosine of x times sine of 2 pi like that. Okay, and then these problems, we just look a couple of things up on the unit circle. So if you're at 2 pi all the way around a circle, then we would know the cosine is 1 and the sine is 0. Okay, so we end up getting sine x times 1. The cosine of 2 pi is 1. Then we have cosine x, and the sine of 2 pi is 0. So we end up getting this. So we get sine of x. So what we just showed, and you're kind of deriving a new identity, and we've already learned this identity in some regard. So it's kind of good in this problem to try to make sense of this. Okay, to me, this is perfectly logical. Okay, if we add 2 pi to an angle, we're just getting the same coterminal angle, right? Okay, so would it make sense that the sine of any angle plus 2 pi would just be the sine of that first angle anyway? Okay, all this is saying is, like, if you had something like, if you had sine of 30, that would be the same as the sine of 360 plus 30. It's the same answer because they're in the same place on the unit circle, right? Okay, just means an extra lap around the circle isn't going to change the value of the trig function. Does that make sense to you? Okay, here's another way to look at graphing. Okay, this would be the graph of a sine wave phase shifted 2 pi to the left. The period's 2 pi, so it'd be the same graph. Okay, so you can make sense of the problems in a couple of different ways, even graphically. Okay, this one, the cosine identity goes cosine, cosine, sine, sine, different sine. So it goes like this. You would go cosine 90 times cosine of x, and then you use a different sign. Just look up the identity until you memorize it. And then it would be sine 90 times sine of x like that. And then we just look these things up on the unit circle at 90 degrees. So at 90 degrees, the point on the unit circle is 0, 1. So that means the cosine is 0 and the sine is 1. Okay, so what you would get here is cosine of 90 is 0 this time. Bring down the cosine of x. The sine of 90 is 1. So we get sine of x like this then. Okay, that would cross out and go to 0, of course. So you'd end up getting sine x. So what we have is we have a, and I'm curious if any of you recognize this identity, because I've already taught it to you. Do you recognize this identity by any chance? What's the relationship between sine and cosine? What do we call the sine and cosine? Cofunctions, right? Okay. How do you find a complementary angle? You subtract from 90. This is the identity we learned for cofunctions. Okay, so it's derived. One way to derive that is through the cosine sum identity. So you've seen that identity before. You really have. Okay, all right. So the next one we'll do a tangent identity on. And the tangent identity for a difference goes like this. You would go tangent alpha minus tangent of 180. Okay, and then the denominator, I always remember you have a 1, a different sign, and then it's the product of the tangents of those two angles like that. Okay, so you just do that, and then really all you should have to do on this is just look up on the unit circle the tangent of 180 degrees. And what you'd have on this then is the tangent of 180 degrees is just y over x. So if you look at this, y is 0, x is -1. So you would get 0, right? So basically everywhere you see tangent 180, just plug in a 0. Okay, so you would end up having tangent of alpha minus 0 over 1 plus tangent of alpha times 0, with that crossing out. So what you would end up getting is you just have tangent of alpha over 1. So you would get tangent of alpha, okay? So what we just kind of, the conclusion we have is the tangent of any angle minus 180 degrees is the same as the tangent. Okay, and let's think about this. Let me just see if this makes sense to you. What's the period of a basic tangent? It's not 2 pi, it's what? Pi, or 180. So what this means is every time 180 degrees goes by, a tangent repeats its answer. One quick way to look at that on a unit circle is, for instance, if you look at this line right here, the tangent has the same value from 30 to 210. They're always 180 degrees apart because they have the same value in opposite quadrants. So that's what that means. If you graphed tangent of x minus 180, it's the same as the graph of the tangent of x. Okay, it's because that period is off by 180. Okay, so you typically will get some fairly logical answers on these problems. All right, let's go ahead and let's finish up this last page here, and then we'll take a break. It's a pretty short section to look at. We're just kind of familiarizing ourselves with these identities. This is an exercise that kind of puts several skills together. So I'm going to do one of each of these kind of problems. So on this problem, what we're doing is we're finding the cosine of a minus b. So I would start the problem just by writing out this identity. And this will basically tell you kind of what we have to do on this problem anyway. So the cosine difference identity is cosine, cosine, sine, sine, different sign in the middle. So it would go cosine A, cosine B, and then plus sine A, and then sine B, like that. All right, so if you look at this problem, I've given you two things. I have given you that the cosine of A is negative 5/13. The other thing I gave you is I gave you the sine of B is 8 over 17. But I didn't give you cosine B sine A, but there's enough information to figure that out. You don't really need the unit circle to complete this problem either. So the second thing I would recommend you do is just look at, we have the cosine of A is negative 5 over 13. The problem says that you're in quadrant 2. So if you're in quadrant 2, x is negative, y is positive, and r is always positive. Okay, so we've seen this kind of situation a lot. So the definition of a cosine is it's x over r. So that means in this problem, x would be negative 5, r would be 13. Okay, like that. All right. How do you find y? You either know it or you do what? Pythagorean theorem. Does anybody know what y would be here? 12. There's two Pythagorean triples I think you should know. You should know 3, 4, 5, and 5, 12, 13. So if you don't know that, then you would go to the Pythagorean theorem. You could use x squared plus y squared equals r squared if you need to. Okay? All right? So that means that what we're doing is we also got to find the sine of A. So we need to know what this is right here. So we have to find the sine of A in this identity. So the sine of A would then be y over r. So that would end up being 12 over 13, like that. Okay. So what I'm going to do is kind of start plugging stuff in. So we were given in the original problem, the cosine of A was negative 5/13. We were given in the original problem, the sine of B is 8 over 17. Now we just figured out that the sine of A is 12 over 13. So we only have one more thing we got to figure out, say. Okay. So the third thing I would do is take the other thing you were given. You were given that the sine of B is 8 over 17. You were also given that you're in quadrant 2. That's a part of the problem. So again, if you're in quadrant 2, x is negative, y is positive, r is always positive. Okay, so again, the definition of a sine is y over r. So that means in this problem, y would be positive 8, r would be 17. Now you can use your calculator to find this. I don't remember what this one is. It's a triple though. What is it? 15? Yeah, that's right. Okay. And again, you can do this if you want to. You could go x squared plus 8 squared equals 17 squared. And then you could, that would be 8 squared plus 64. I don't remember what 17 squared is. So what's that, 289? Yeah, this will work out, but, and then you subtract the 64 from both sides. You don't have to show all these steps because you can do this in your calculator. And then that would be 225. Then square root both sides, you get x equals 25. So if you don't know the Pythagorean theorem, then just, or the Pythagorean triple, just crunch it out. Okay. So the next thing we'd get is cosine B. We also have to find cosine B. So that is x over r. So that would be negative 15 over 17. So that would get plugged in. And then we're ready to get the answer of the problem like that. Okay? All right, you guys understand what I'm doing okay? So if I give you a trig function and a quadrant, you can always figure out the other trig functions. And that's kind of what you have to do in this problem. So now if you multiply everything out, I'll use my calculator to kind of help me a little bit. If I do 5 times 15 is 75, and that's what did I do there? If I did the wrong thing. So I got 5 times 15 is 75. And 13 over 17, I'm going to take 13 times 17. So that'll give 221. And then the next one, I think 12 times 8 is 96. 13 times 17 against 221. So now you can just take 75 plus 96. And the answer of the problem would then be 171 over 221. Okay, now notice in that problem, we never had to figure out what the angles were. It didn't matter, okay? We just had enough information to use the identity and our definitions of trig functions to figure out the rest, okay? That's the most complicated problem you do in this section, it really is, okay? All right, let's do one more of these and then we'll take a break. Any question about what I did there? Okay, I'm going to do one of these, I guess, with a sine, and it's going to be a fairly similar thought process on this. It's just a different identity. So this one, I would start by writing down the sine sum identity. So we would go sine A cosine B. It's got the same sign, and then backwards you would go cosine A sine A like that. Okay, and again, with this problem, we're given a couple of things. We're given what the cosine of A is, and we're given what the sine, I think I got the wrong angle there. I wrote that down wrong. So that would be sine B. Okay, so I'm given these two things here. So the strategy behind this problem is pretty similar. That's going to be 1/3 goes there, negative 1/2 goes there. Okay, things are just in a little bit different place. So again, I do the same idea. So the second thing is we'll work with the cosine of A, which is given as 1/3. And this one we're given is in, that said, quadrant 1. Okay, so if you're in quadrant 1, that means x is positive. No, it's quadrant 1. I think it says, I think the last problem said both were in quadrant 2, so you're good, okay? So y is positive, r is positive. So quad 1, everything's positive. So what this would mean then is the cosine's x over r. So that would mean x is 1, y is 3, not y, r is 3. And then we can use the Pythagorean theorem to find what y is, okay, which we'll need to find. So we basically have x squared plus y squared is r squared. So you'd have 1 squared plus y squared equals 3 squared. So that would be 1 plus y squared equals 9. You can subtract 1 from both sides, and you can do some of this in your head. So that's y squared equals 8. Square root both sides, and you would want to break that up into root 4 times 2, so you'd want to simplify that to 2 root 2, okay? So you would end up getting 2 root 2 would be what y is. Now, in this problem, we have to find the sine of A. Okay, so the sine of A is going to be y over r. So y is 2 root 2, r is 3. So that means this plugs in like that then. Okay, same idea as the last problem. You just got to be sure that you pay attention to the quadrant and the signs. I have to give you the quadrant, otherwise you couldn't narrow down what the signs were. And then the third thing you were given is the sine of B is -1/2. And this one was quadrant 4 is what you were given if you read the problem. So that means x is positive, y is negative, r is also positive like that. So pay attention to your signs. And again, what happens on this, the sine is y over r. So you would end up having y would be -1, r would be 2. And you can do Pythagorean Theorem. You'll get square root of 3 on this, though. I'm not going to take the time to do that. But, and that one's kind of from the triangle, the 1 square root of 3, 2. But you can do that on the Pythagorean Theorem, and you can get that figured out. So then what I would have is I'd have to do the cosine of B, from my identity. So that's x over r. So x is root 3, r is 2, so you get root 3 over 2. And I know that from the unit circle too, right? So I'd end up getting, for cosine of B, I would get square root of 3 over 2. So now finally I got everything I need to know, then I can put everything together. Okay, so what I would get is, multiply this straight across. Now I would go ahead and, I wouldn't cancel out the 2's because I need a common denominator anyway. So this would be 2 root 6 over 6. Then the second one would be -1 over 6. So then just write the answer as 2 root 6 minus 1 over 6 like that. That's it, okay? So that's a good exercise just to kind of review lots of things, quadrants, Pythagorean Theorem, definitions of trig functions, okay? A little bit of work involved in that, but it's not hard to do. Okay, you guys follow what I did okay on this section, you think? Okay, generally, this section's pretty smooth. I think most of the rest of the stuff we do this semester is not hard to learn. Okay, and that's kind of good news for pre-calc students and trig students. It always finishes with some of the easier material. Okay. All right, so let's go ahead and take a break, and for about 5 minutes, come back, and then we'll do the 6-6 section. If you didn't pick one up, there's some copies up here too.